Here we are back in our little land here of your friend's house, your house, and Publix. But now we're going to look at a new quantity which is very similar to speed, but which is different from it, and that is average velocity. As I have said, velocity and speed are two different things. They're different things. We've already calculated the average speed for each of these three trips. Now we're going to calculate the average velocity. But, as before we can do that, we have to define average velocity. So, get ready. Here it is. Average velocity. Average velocity actually has a symbol, v sub AV. It is defined as not the distance over elapsed time, but it's defined as the distance, as the displacement over elapsed time. The average velocity is delta x. Actually, let me write it out this way. Let me write it out this way for you all. Write it in words first, and then I'll put it in math. The average velocity, v sub AV, the symbol here, is displacement, not distance, but displacement over elapsed time. Or delta x. Remember, delta x is our symbol for displacement. Delta x over delta t. Okay. It's got a more mathematical definition to it. Average velocity. Not the same as average speed. So let's do our calculations now. In each of these cases, each of our three trips define the average velocity for each of these trips. Okay? So let's do it. Trip 1. V average is delta x over delta t. We've already found delta x for all three of these. We've already found the displacement for all three trips. Look back in your videos, look back in your notes. I hope you're taking notes. Many of you probably helps you a great deal to take notes, if not all of you. So this is going to be 4.3 miles, right? Delta x is x final minus x initial, rather, over t final minus t initial. Little side note here, okay? Little side note. When you see a delta something, whether it's delta x, whether it's delta t, or as we'll see later, a delta v or a delta e or whatever, when you see a delta, that means final value minus initial value. So delta elephant means final value of elephant minus initial value of elephant. Doesn't matter what the thing is. Okay, final value minus initial value. So delta t is a shorthand way of writing final time minus initial time. Now we're going to assume in all three cases that we start our watch off, our stopwatch when you leave your house. Okay, that's when the clock starts to run. So ti for us in these cases, not in all cases, but in this example here, ti is going to be 0. Okay, the final time. Initial final time is what your stopwatch shows when you get to the end of your trip. The initial time is what the stopwatch shows when you started your trip. We're going to assume the initial time is equal to 0. Okay, so let's find delta v average for trip 1. Well, what's your final position for trip 1? It's 6.4 miles. What's your initial position for trip 1? Your house, 2.1 miles. Right? Final time was 0.15. Our initial time was 0. So you do your maths here, and you get 29 miles per hour, which is exactly the same as the speed the average speed for that trip. If you look back at last video in your notes from it, you'll see that the average speed for trip 1 was also 29 miles per hour. So in this case, they show the same thing. Average speed, average velocity show the same thing. Trip 2, the average, well, it's going to be xf minus xi, right? Final position for trip 2, right? Initial position is u. Final position is u. You're at 2.1 miles. So 2.1 miles because you end up, xf is 2.1 miles, right? xf is 2.1 miles. Your initial position for trip 2 was also 2.1 miles. Remember, this is the one where you start and stop at the same place. So xf is 2.1 miles. I should probably say x sub f is 2.1 miles, and x sub I is 2.1 miles. Subscript. Sub means subscript. T sub f, the final time, is 16 minutes, or 0.26 repeating hours. Again, we're starting our time off at 0. Initial time is 0. That's pretty standard. So what we get here, doesn't matter what's in the bottom. Doesn't matter if there's a millisecond in the bottom or if there's a million years in the bottom, because we've got 2.1 minus 2.1 in the numerator, which means we get 0. So your average velocity for trip 2 is my favorite number, 0. Your average velocity is 0. That's not intuitive. All right, the average speed for that trip was 32 miles per hour. The speed from your house to Publix and back, your average speed was 32 miles an hour. But that was average speed. The difference being distance was in the numerator here, not the displacement. The displacement is 0 because you ended up where you started. You ended at your house, you started at your house, so your displacement is 0, so your average velocity is also 0, because the average velocity depends directly on displacement. It is proportional to displacement. If displacement is 0, average velocity is 0. So your average velocity for the whole trip was nothing. Okay. You can sort of think of it like you had some positive velocity going, but then you had negative velocity coming back home. Positive velocity going this direction, negative velocity going that direction. They sort of cancel out. Think of it that way if you want to. They cancel out. End up with 0 average velocity. Trip 3. V average. Again, what's x sub f? What is the final position that you end up at for the third trip? Well, you end up at your friend's house. You go from your house to Publix to your friend's house. So your final position is my favorite number, 0, because you end up at 0 for the third trip, right? Minus x sub I, right? That's what this means. Delta x is xf minus x sub I. So your initial position was 2.1 miles. You started the whole thing off, the whole trip. Trip 3, you started off at your house, so it's minus 2.1 miles, right? X sub f is 0 because you end up at 0. X sub I is 2.1 miles because you started at your house, which is located at 2.1 miles. Total time, I think, was 0.30 hours. And again, we're starting off our stopwatch when you left your house initially. So the initial time, T sub I, goose egg, 0. So your average velocity is negative 7.0 miles per hour. Okay. Make a similar point here. Listen up. Give yourself a moment to pause and catch your breath. Listen up. Speed. Remember, average speed was defined as distance over elapsed time, right? That is average speed. Remember that distance is a scalar. There's no direction to distance. Your odometer in your car doesn't tell you, right, what direction you went when you were adding up the miles. It just tells you how many miles you went. There's no direction associated with it. So distance is a scalar. Therefore, average speed is a scalar. In the same way, for velocity, for average velocity, displacement is a vector. It has direction to it. Therefore, the average velocity is a vector. So average speed is to distance as average velocity is to displacement. And these signs you see here, there's an implied plus sign. There's a little ghost-like plus sign floating out here in front of this 29. I'm not going to draw it. But there's a little ghostly little, you can imagine it. You're all very alert and you've got active imaginations, and you can imagine a plus sign floating around in front of that 29. That implied plus sign is significant. It tells you that because average velocity is a vector, it tells you that you ended up to the right of where you started, whether in the positive direction along the number line, right? I should have put this here, positive x direction. It means that you ended up to the positive side of where you started. You ended up at a higher value than where you started. Put in terms of velocity is this. Velocity, when you go from your house to Publix, you're going in the positive direction. This 29 miles per hour is in the positive direction. You're moving in the positive direction, therefore it's positive. Your final position is at a higher value of x than your initial position. You are moving to the right, moving in the positive direction. In case 2, you didn't move at all. You went nowhere. You started at your house, went to Publix, and returned to your house. Okay? So overall, your whole trip, you went as far to the right as you went to the left. Those two, right, equal amounts. So the displacement is 0, and so your velocity, your average velocity is 0. Trick number 3, there's the negative sign. We have to be explicit about that. We're not explicit about the positive sign in front of the 29 because we just don't put positive signs in front of numbers. We assume numbers are positive unless we're told otherwise. In the same way that implied positive sign had physical significance, that your average, that you were moving on the average to the right, this negative sign has physical meaning. It tells you, or rather has direction meaning. It says something about your direction. It says that you ended up to the negative side of where you started. You started at your house, you ended up at your friend's house. Your average velocity was in the negative direction. Okay? Your average velocity was in the negative direction. So these signs for average velocity carry directional meaning. All right? Average velocity can be positive or negative, and it is a vector. Okay. In other words, the positives and negatives carry directional meaning, unlike the positives and negatives, say, for the temperature of a room. Right? Positive 20 degrees, negative 20 degrees. Says nothing about direction. Right? That's a scalar. But for a vector, positives and negatives have a directional meaning. Okay. Your average motion was to the right, average motion was to the left, or whatnot. Okay, next up, slightly different take on speed and velocity. We'll kind of bring it all together. All right, see you then.